For the longest time, 3D printing was basically this cool toy, right? For making little prototypes, maybe some plastic trinkets, but that's old news. Today, we're going to talk about how artificial intelligence is taking that same technology and turning it into a smart, adaptive manufacturing powerhouse. Seriously, it's changing how we build everything. All right, let's just jump right in with a wild question. What if an AI could design a part that's, get this, 64% stronger than what a human engineer could come up with? And here's the kicker, using the exact same amount of material. Sounds like something out of a sci-fi movie, right? Well, as we're about to see, it's not sci-fi anymore. It's happening right now. So why is this such a game changer? Well, to really get it, you have to look at let's call it the dark side of 3D printing. The promise was always awesome, click a button, get a perfect part. But the reality, oh man, so many failed prints, warped materials, hours and hours wasted. And your designs were always limited by what a human could actually draw up in a program. It was this amazing technology just bursting with potential, but kind of held back by all these frustrating real-world headaches. Okay, so the whole process, and the fancy name for it is additive manufacturing, or AM. You can pretty much break it down into 4 main stages. First, you have the design. Then there's pre-processing, which is basically getting the file ready for the printer. Next up, the main event, the actual printing. And finally, post-processing, where you clean it up and finish it. Now here's the thing, the really crucial point. AI isn't just making one of these steps a little better. Nope, it is revolutionizing every single one of them. Okay, hang on. Before we dive deeper, let's just get on the same page with some of the lingo. You hear AI, machine learning, neural networks thrown around all the time, and it can get a little confusing. This diagram here makes it super simple. Just think of artificial intelligence as the huge overall idea of making machines smart. Machine learning, that's a specific way of doing AI, one that learns from data. And neural networks, that's one of the most powerful tools inside the machine learning toolbox. See? It all just kind of nests together. All right, let's start where it all begins, the design phase. And honestly, this is where some of the most mind-blowing stuff is happening. We are moving way beyond using software as just a fancy digital pencil. Now AI is becoming a legitimate creative partner, coming up with things a human being might never, ever think of. So yeah, let's pull up that lifecycle map again and really zoom in on that first box, design. This is where that digital blueprint gets created. For decades, this was all on the human engineer, right? It was all about their experience, their intuition, their best guess. Well, that's all changing. The technology that's driving this is called generative design. And it's not AI taking over, it's a true collaboration. It works like this. The human designer lays out the rules. They say, okay, AI, I need a part that connects this point to that point. It has to handle this much force, weigh less than a pound, and be made out of aluminum. And then the AI just goes to work, generating hundreds, maybe even thousands of different designs that all fit those rules. And they often look weird, kind of like alien bones or something, but they are perfectly mathematically optimized for that specific job. And look, this isn't just theory. We've got the hard data to prove it. Check this out. Researchers in Pune did a head-to-head competition. They designed a bracket the old-school traditional way. Then they had an AI design one using that generative process we just talked about, with the exact same amount of material. They 3D printed both and put them to the test. The human-designed part, it broke when they put about 26 kilograms of force on it. Not bad, but the AI's design, it held on all the way past 43 kilograms. That's a 64% increase in strength. I mean, just let that sink in for a second. This wasn't because they used more material or some crazy expensive new plastic. Nope, this was purely from a smarter design. The AI just found a ridiculously more efficient way to arrange the exact same amount of material to handle stress. That one number, plus 64%, that tells you everything you need to know about the power of this. Okay, so we've got this incredible superhuman design. Awesome. But a brilliant blueprint doesn't mean a thing if the printer messes it up, right? So what about the printing process itself, with all those potential failures? Well, this is where AI puts on a different hat. It goes from being a designer to being a super smart technician, creating printers that can literally see, learn, and fix themselves as they go. And we're back to our roadmap here, moving into those crucial middle stages, pre-processing and printing. This is really the moment of truth. It's where that perfect digital idea has to become a flawless physical thing. And, historically, this is where most of the headaches, the wasted plastic, and the frustration would happen. So how exactly does an AI make a printer smart? It's not just one thing, it's a bunch of things working together. The machine learning models, they analyze data from thousands of old print jobs to get more and more accurate. They can actually predict that a certain sharp corner on your model is probably going to warp, so it adjusts the fan speed before it even becomes a problem. It can optimize all those little support structures so you use way less material and it's easier to clean up later. It's basically like having a tiny expert technician inside the machine watching over every single layer. But maybe the biggest game changer is this idea of real-time quality control. Just picture a tiny camera inside the printer, watching every single layer of your part as it gets printed. An AI, which has been trained to spot even the tiniest mistakes, compares what it sees to the original digital file. If it spots a problem, like a little blob of plastic where it shouldn't be, or a bit of warping, it can instantly tweak the printer settings to fix it on the very next layer. And the results are just staggering. Industry reports say this can cut down on failed prints by up to 80%. I mean, think about the savings in time, material, and money. It's huge. So we've got a smarter design, and we've got a smarter printer. But when you put those two things together, that's when you unlock something truly profound. You get the ability to build whole new classes of objects. As we're about to see, the future is incredibly lightweight, and it's filled with these amazing structures that were, until now, basically impossible to design, let alone actually build. And that brings us to the last stop on our map, post-processing. But this isn't just about snapping off supports and sanding things down anymore. Nope, AI has a huge role to play here too. By analyzing all the data from the printing process, like tiny temperature changes and how consistently each layer was printed, machine learning can now accurately predict the final strength and flexibility of the finished part. And it can do that without having to destroy it in a stress test. It's the ultimate quality check, making sure the part you designed is the part you actually got. So, what are these impossible structures I'm talking about? Well, a perfect example is something called a lattice structure. So instead of a solid chunk of plastic or metal, imagine a complex web-like internal geometry. Think about the inside of a human bone or a honeycomb. These things are unbelievably strong for how little they weigh. And that combination, strength and low weight, is like the holy grail for industries like aerospace, automotive, and even medicine. But here's the catch. Trying to design one of these things by hand, it is insanely, mind-numbingly complex for a human brain. But for generative AI, it's the perfect job. It can design the absolute optimal lattice for whatever you need it to do, maybe absorb the energy from a car crash, for example, while at the same time making sure the design is actually something a 3D printer can handle. It completely takes the guesswork out of the equation and lets us create parts that are just fundamentally better, lighter, stronger, and more functional than any solid part could ever be. So, when you step back and look at all these pieces together, the AI designer, the smart printer, the impossible structures, it becomes really clear that this isn't just a small upgrade. The combination of AI and 3D printing is a fundamental shift in how we even think about making things. I mean, the difference is just night and day. The old way, 3D printing was a tool for making prototypes. It was a process of trial and error. The new way, it's a full-on end-to-end production system. It's driven by a human-AI collaboration that is predictive, it's adaptive, and it has quality control built right in from the very beginning. It's a whole new paradigm. And look, this isn't just something happening in a few research labs. A big review of academic papers shows exactly how AI is being put to work in the real world. The most common jobs for AI are regression, that's predicting outcomes, like how strong a part will be. Then there's classification, that's spotting those tiny defects in real time. And clustering, which helps group similar designs to estimate costs and things like that. These are the practical, real-world jobs AI is doing right now, across that entire manufacturing lifecycle. I think this quote from tech writer Peter Planka just sums it up perfectly. He says AI has turned what was a manual hit-or-miss process into precise automated manufacturing. That really nails it, doesn't it? It's all about moving from a craft, which can be inconsistent, to a science, where AI brings the precision and the intelligence. Which brings us to one last really exciting question. We've seen how AI can help us build parts that are 64% stronger. We've seen how it can slash print failures by 80%. If that's what AI and 3D printing can do today, what truly impossible things are we going to be printing tomorrow?